Today we're going to, this is the last class, okay, for this elementary math class. Today we're going to study the set theory, okay. The set theory, how to use a set theory to understand, to solve some problems. And so let's begin with the first problem. If you have, here's a question. There are 48 students in class. Among them, 37 students complete the English homework and 42 students complete the math homework. Now, we also know that every student completes at least one homework, okay? So you're given in the easy English or math. Now, how many students, how many students complete the English homework and the math homework? Now, to solve this problem, we use a so-called set to draw the picture. Okay, here's a picture. The set, okay? So those are the students, number of students complete the math English homework. And this is the set, students complete the math homework, okay? And so every student either complete the math homework or the English homework. So there must be in the union of those two sets, okay? But there's overlap. So the overlap part will be the students who complete both homework. So we are asking for the overlap part, okay? So how do you solve this problem? Well, the students who complete the English homework will be 37, right? And if we add them together directly, and the student who complete the math homework will 42. But if we add them together, it'll be definitely more than 48 students, right? More than 48 students. So why there's more than 48 students? Because you double counted those who, the same person, you double counted those students who complete both homework. So you add them together. How do you find this double count per people, right? So actually, it's going to be, you can do this way: 48. Okay, that's a total number of students plus those number who double counted. Okay. Okay. This is the equation. We call the equation both sides, okay? And left-hand side is just the sum of the students who complete the English homework and sum of students who complete the math homework. But when they add them together, you will get more than the total number of students. Why? Because the sum are double counted. So you have to make sure if you want to put both sides equal, then and want to make sure both are equal, then you have to add the number of students who double counted, because otherwise they're not equal to each other. Okay, so you can also do this way. Then this number is going to be 37 plus 42 minus 48. That difference gives you the total number of the students who that gives the number of students who complete both homework. Okay. So you can quickly, then as long as you use this idea, then you can solve the problem easily. So there'll be 31 students. Okay. That will be 31 students. So 31 students complete both homework. Okay. Okay, you guys didn't listen to me, okay? I see you're typing completely different messages in the chat window, okay? I have to call your name. Jensen Shao, what are you doing there? And Michael Maxwell Lee. Okay. Let's do the next problem, okay? The next problem will be, here, before we do the next problem, let me try to list give you the general formula. Okay, so if you have a set, okay, we call it A, another set we call the B. Now this notation is called the uni of A and B, and this notation is called the intersection of A and B. Okay, and the idea is that if the number elements in the set A plus the number elements set B, and this is going to be more than the elements in the uni of those two sets, but that's the intersection. So actually, you have to add the double counted part. So this is identity. Okay. So we're going to use this idea over and over again for the next problem, for the other problem in similar problems. Okay. So here's a similar problem. You know, you can use the same idea. Okay, draw the picture. Okay, so there are 54 students in a class. Every student subscribe a magazine A or magazine B or both. Okay, so or both. Okay, it's possible some students subscribe to both magazines. Okay, if the 13 students subscribe both magazines, okay, and the 45 students subscribe magazine A, and then you want to figure out the number of students who subscribe magazine B. Okay, so please turn off your video. Okay, I don't know who did. All right, and what we know is we're in the intersection part. We are given the intersection part. Okay, so first of all, let's see. Okay, what we're given. We have a 54 students, right? So if you use a notation, that is a unit of those two, okay, sets can be 54, right? We're given the information. We also given the information, the intersection, because 13 students subscribe both magazines. Okay. We also know this number of students subscribe magazine A, which is 45. We want to find out the number of students who subscribe magazine B. Okay. Now you can use that part above formula. You can immediately solve the problem. Yeah, because 45, right, plus the number of students subscribe magazine B, and should be equal to the total number of students plus the students who subscribe both magazines, which is 13. Okay. Then from here, you find the number of students who subscribe magazine B. I'm going to show you a slightly different way. Okay, so now you have 54 plus 13 minus 45. So that will be 22. Okay, that will be 22. So it will be 22 students who subscribe magazine B. Okay, did you get the same answer? Oh, no. Right, 22, yes. All right. All right, and yeah. So on the picture, you can write like this. This is 13. Those are student double counted. And here, you don't know, right? This is a 45. A total will be 54, right? 54. So you want to know the number of students in B, right? In this group of B, you know, who subscribe the magazine B. So this is a number of students you don't know. We call it X, right? So now how do you, forget the formula. Just look at this picture. You will see that 45 plus X, right? And then you can also, you want to calculate how many students there, right? So 45 plus x gives you, we actually give you more than the total number of students in the union of those two sets, right? So so there are 13 students double counted, so you have to subtract 13. Then you get total number of students, because this is another way to look at it, okay? And then from here, you simplify the equation. Then you can solve for, you can move 13 to the other side, and you get similar, 54. You can add both, 13 plus, add 13 to both sides, and then you get, then you actually get x, 54 plus 13 minus 45, and finally simplify it. It's going to be 22. Okay, so this is how do we solve the problem. Okay, so you try to figure it out, the total number of students, okay, by adding students from the both groups, okay, and then you have to subtract the number of students from in the intersection area. All right, so here's another one. So we have a team of 10 students from TWE, okay, participating in 2 contests, English and math. Okay, we know that everyone in the team won at least one prize. So among them, 3 students won both prizes, and 5 students won a prize in the English contest. So how many students won a prize in the math contest? So still will be a pretty similar situation here. So you get a picture, okay, right? So this is an English contest, right? This is a math contest, okay? So the idea is, forget the formula. The idea is how to calculate the total number of students who participate in in the contests, okay? So we know that 3 students won both prizes, so in the middle, okay, that's the 3 students, right? And the 5 students won the prize in English contest, okay, 5. And we don't know how many students win the math contest, right? Okay. So how do you calculate? Suppose you're not told the number of students who participated in both contests, right? The contest, 2 contests, right? Then how do you calculate the total number? Well, 5 plus x, okay? 5 are also students who participate in an English contest, right? X, we don't know, right? And this is the number of the students who participated in the math contest. If you add them together, you will not get the total number of students in the team. You have to subtract those double counted, so because double counted, so that's 2 layers there. Subtract 1 layer, then then you get the total number of students, which should be 10. Okay, and from here you will get, it's simple. 5 minus 3 is 2. 2 plus x equals 10, and this is a simple equation. Okay, and in the basic math class, we're going to learn more complicated equations. Then you subtract the 2 from both sides, so you get 8. Okay. All right. So this is still 3 problems are very similar. Now I guess you can easily understand than the other type of story problems we studied before. Okay. So number 4. Okay. Number 4. In class of 40 students, 19 students join a math club and a science club, but 11 students do not join any club. Okay. join both clubs. Okay, 19 students join both clubs, science and the math. We know that there are 25 students join the math club. How many students? Yeah, how many students join join the science club? Okay. Okay, I let teacher try first. Okay, when you have an answer, just type the answer in the chat room. Okay, so so here's the point. Okay, how to draw the picture. So let's see, math club M. I use M, right? And the science club I use S. Okay, so let's back it. So we have 19 students in the both clubs. So here's 19. Okay, this is the intersection part, right? And the 11 students do not join any club. So there'll be, you see here, this is the whole class right now. 11 students be outside these two clubs. Okay, and the 25 students join the math club, 25 total. Okay, and so so let's estimate the number of students join the science club. Okay, so how can I calculate the total number of students? Well, first of all, you have to find out the number of students in this group. Okay, so they are either join the math club or science club or both. Okay, so this is the number of students will be 25 plus S. Okay, and because 19 students join both clubs, you have to do such student double quantity for each, add them together, right? You know, that's overlap, right? So you have to subtract 19. When you subtract 19, you get the total number of students in this group who either join the science or join science club or math club or both. But there are some students, okay, who do not join any clubs, so that's 11. The total will be 40. So I want to see an equation like that, okay? And then you just simplify this equation, right? Step by step. So first of all, you do 25 minus 19 and the plus 11, that'll be 17. Okay, then how do you get the S, right? Then subtract 17 from both sides, right? You will get 23. So there are 23 students, okay, who joined the science club. 25 joined the math club. Okay, can you see that? So this is kind of like an idea how to set the equation. Equations means on the one side you calculate using just calculate based on what you're given. And maybe there's some unknown quantity there. On the right hand side, you already know the total number like that. Okay, so you just then that should be equal. Then you set up the equality. Then you get so-called equation. Okay, and this kind of equation are simplest equation. They are just linear equation. There's only one variable, one unknown there. Okay, that's only one unknown variable here. Okay, do you understand how do we set up equation, right? We're trying to calculate, the total number of students based on the given information. Suppose we don't know how many students there are 40, right? So right side is already we know 40, but the left hand side we're trying to write down the expression which represents the total number of students. Okay, that expression involves this unknown number. That number represents the students who joined the science club. Okay. All right. So this is a key part we learned, at the very beginning. Okay. So A plus B. So let me repeat it again. Here's a picture. Okay. So if you set A and set B, and this is the unit of A intersection, right? So the number of students in the unit of those two sets will be the number of students in the A plus the number of students in the B, but then you have to subtract the overlap part. Okay. Okay. Those are who are double counted. Okay. This is a formula I keep using, a different version of the formula. Okay. All right. So now let's look at the next problem. There are 56 students in one class. 28 students participated in an English contest, 27 students participating in a math contest. There are 25 students who did not attend any of these two contests, okay? And attend, any of those two contests. How many students participate in both contests? Okay. What do you got? Right, so it's a very similar problem, right? So first of all, let's draw the picture, okay? The whole class, here's a student's number of students participating in the English contest, okay? That's 28. And then we also have, we know that 27 students participating in the math contest, okay? And there are 25 students who did not participate in any of these two contests. 25 is outside, okay? Outside this group, right? Outside. Okay, so the total, this is the whole class. Okay, so let's calculate, and then the students who participate in the both contests we call the X, right? Okay, so let's calculate the total number of students in this way. And as the number of students who participate in the English contest is 28, and the minus 20, plus 27, but that's more than the total number of students who participate in either, in some contests, right? In some. So you have to subtract those overlap, or double counted. And this is the total number of the students who participated in at least one of those contests. So you have to add the 25 to get the total number of students in the class, which is 56. So you get the equation, okay? Right? Then you simplify it. Plus 25. So actually this side is 80 total minus X plus 56. Now this is a little bit strange equation, right? I have a minus here, right? So how do you solve this problem? How to solve this problem? Well, you just like as equations, okay? You can subtract the 56 from both sides, right? Then the other side becomes 0. So right, 56, right? 80 minus 56, you get 24. So 24 minus x equals 0, then that x should be equal to 24. Okay, good job. Yeah, do this. Okay. All right. So the key formula we used here, still this one. You know, that's how do we get this total number of students who participated in one of the contests or both. Okay. So this problem is similar to the problem number 4, right? But it's similar to that. Okay. Now we see if we can. Let's look at the next problem. Okay. And then we are going to study different type of problem. Okay. There are 103 people in a club. Among them, 69 people can play Chinese chess, okay? 52 people can play Chinese, you know the game called Go, okay? But there are 12 people, well, not necessarily students, okay? 12 people, there are 12 people who can play no of them, okay? So question is, how many people can play Chinese chess and Chinese Go? Right. Okay, so let's draw the picture. Okay, okay, still the same picture, right? And 69 people can play the Chinese chess. Okay, 52 people can play the Chinese Go. Okay, 52. Okay, and there are 12 people who can play no of them, which is all side. Okay, that's 12 people here. Total, that forms the group, right? The club. So let's, based on that information, to calculate the total number of people in the club, and denote by X the number of the people in the intersection. That means they can play both Chinese chess and Chinese Go. Okay, so first of all we calculate the number of people in the union of those two groups. Okay, the union of those two groups means those are the people who can play at least one. Okay. Okay, at least who can play one of the game. So 69 plus 52. Okay, and then minus X. Okay, because why have the minus X? So because it's if you want to get a total number of people in this subgroup, right, who can play at least one of the game, and if you just add those two numbers together, you double counted the number of people in the middle, right? So you have to subtract the X from the sum, and then you add 12, yeah, plus 12. Those are the people who cannot play any of the games. Then you end up with 103. Okay. Right. Then you just do the calculation. Okay, so 69 plus 52 plus 12 is going to be 133 minus x equal 103. Okay, now then you subtract 103 from both sides, and you will get 30 here. 30 minus x equals 0. That implies x equals 30. Okay, good. All right, those are the problems we know how to do it. Majority of students can do it. Okay, so now let's talk about number theory. Okay, a number, it's about the multiple of a number. Okay, it's about multiple of a number. When we give an example. Okay, 24 is going to be 3 times 8. Okay, okay. Then we say that 24 is a multiple of 3. It is also a multiple of 8. Okay. Now we can also say that 24 is divisible by 3. We also say that 3 is a factor of 24. Okay. So there are many ways to talk about this identity. I can replace 3 by 8. 24 is a multiple of 8, and 24 is divisible by 8. 8 is a factor of 24. Okay. Of course, you can continue to factor 8. That will be 2 times 2 times 2. Right? And then also 24 is a fact, is a multiple of 2. Okay. 24 is a multiple of 2. 24 is divided by 2. 2 is a factor of 24. Now, in the basic math class, maybe we're trying to count how many factors does 24 have. That's a little bit complicated. Okay. Then we, it's just too many there. Okay. Yeah, there are some numbers that this, okay. So 24 is a number divisible by both factors. Because there are some numbers only divisible by one number. Okay, for example, let's see. Let me talk about 12, right? 12 is divisible by 3. It is also divisible by 4. Okay, right? But the 15 is divisible by 3 only, not by but not divisible by 4. So there are some numbers not divisible by 4. Those are some numbers can divide by both numbers, but there are some numbers can only divide by only one numbers. If you're given 2 numbers like 3 and 4. So we want to count those numbers who are divisible by one number. For example, okay, here's a question. Okay, how many numbers, okay, natural numbers, okay, from 1 to 50, okay, and divisible by 3, okay. Divided by 3, okay. So how do you understand this problem, divided by 3? Well, you can list all of them, but there's too many, all right? Too many. So we are going to, it's not easy to solve this problem, right? You can't, right? From 1 to 50. If I only give it like from 1 to 10, and then say, okay, 6, 3, 6, 9, we have 3. Okay. So how do you do this problem? Well, you just need to count the multiples of 3. A multiple of 3 is 3 times some number, right? This is a between 1 and 50, right? So my question is, what is the largest number you can get here for this unknown factor, right? So you have 50 divided by 3. Let's say 50 divided by 3 is going to be, 50 divided by 3 is going to be 16.66. Okay. So that means the largest possible number you can put there is 16. Okay. 16 is the largest multiple that you can get. Okay. So 3 times 16 is going to be 48. Okay. So 48 is the largest multiple, okay, between a multiple of 3 between 1 and 50. Okay. But then you can count, okay, you can count those multiple of 3 here now, because this number is 16 is the largest one. You can change it to 14, 15, right? 15. So that number can be from 1 to 16, any number you can choose. So that's why total there are 16 multiples of 3 between 1 and 50. Okay, so you get this idea. But how do we count? The multiples of 3? Okay, if you okay, during the class, please do not touch anything. Just like video, don't turn on the video. Okay, you disturb other people. Okay, don't turn on the microphone. All right, so let's look at this next problem. How many numbers from 1 to 100 are not divisible by 5, not divisible by 6? Oh my God. Okay, I wanted to try it first. So you have to, the hint is, you actually, let me draw the picture here. This is a picture, right? Okay, it's the 100 numbers. Okay, you count those divisible by 5. You count those divisible by 6. Okay, after you delete those numbers which are divisible by 5, after you delete those numbers which are divisible by 6, then the remaining numbers are not divisible by 5, not divisible by 6. Clear? That's my hint. It's a little bit difficult, right? Okay, are you getting the same answer? Some still giving 4, 5, 6. You see, now I have all kinds of different numbers now. I think we needed to find the total number of integers which are divisible by 5 or 6. Okay. So how many numbers divisible by 5, which is less than or equal to 100, right? Let's get the largest number here. And this is going to be 100 divided by 5, right? 20. So you have a 20 integers divisible by 5, okay? But how many integers are multiple of 6. Then you have to do 100 divided by 100 divided by 6. It's still 100 divided by 6 is 16.6, right? So that means I have 16 multiple of 6 from 1 to 100, just right? That's how to get it. But a number is divisible by 5 and 6. That number must be divided by 30. Okay? So here's the point. Let me put a note here. A number is divisible. I want to see the intersection part. Divisible by 5 and 6. It's if and only if it is divisible by 30. Why? 30 is 5 times 6. Okay? 5 times 6. Please turn off your video. I said it many times. Okay? 5 times 6. So 30 times some number should be less than or equal to 100. So I'm pretty sure this number, there's only 3 here. 3 point something. Okay? 3.3. So how do we calculate the number of integers in this group? In this group circled by the yellow color. Okay? Then that is going to be the total number, the number of integers divisible by 5 or 6 or both, okay, is going to be 20 plus 16. You have to minus those divisible by both. Okay? So that is going to be, okay, right, 20 plus 16 minus 3, it's a 33. Now 33, okay, 33 are the number of integers divided by either 5 or 6 or both. But we are looking for the number of integers which are not divided by 5, not divided by 6. So my answer to the question will be 100 minus 33, 67. Okay, so 67. All right, so now let you try, okay, the next problem. So among the numbers from 1 to 200, how many numbers are not divisible by 5, not divisible by 8? So can you do this now? Okay. So we draw the picture again, right? Total we have 200. And then we write down this is divisible by 5. And then we also have those numbers divisible by 8. Now, if you can figure out all those numbers divisible by 8 and 5 and or 8 or 5, then you use a subtraction, you get the answer. Okay, so how do you do that? Okay, step 1, you count those divisible by 5, which is going to be here 40, right? Then 8. Okay, let's see the upper bound for the factor. This is the upper bound for the factor. 8 divided by yeah, 200 divided by 8 is going to be 25. So you have a 25, yeah, you have a 25 multiples of 8 there, right? Because 8 times 25 is exactly equal to 200. So it can have 8 times 24, 23, 20, right? Now, you also look at the intersection part, divisible by both. Then it has to be 40 times this, okay? And that implies, right, it's going to be it's going to be 5, okay? So there are 5 factors, there are 5 integers a multiple of 40, okay? So the total number of integers divisible by 5 or 8 or both is going to be, it's going to be the sum minus 5, right? The total number of integers divisible by 5 or 8 or both is going to be 40 plus 25. But 40 plus 25, and you have to subtract those integers double counted, which is 5, okay? So the answer here is 60, okay? And this is for the integers inside this smaller group, right? So my answer will be 200 minus 60, so 140, okay? But good. So now let's take a look at next one. I hope you can finish it by yourself. Among the numbers from 1 to 100, how many numbers are divisible by 6 or by 5? Okay, that's direct forward. Okay. Okay. So just look at this 2 step. Okay. So this side divisible by 6, and this side divisible by 5. Okay. And yeah, let's do the calculation. Okay. 6 times some factor should be less than or equal to 130. So that factor cannot be larger than 130 divided by 6. So it's less than 21 point something, right? And then 5 times some factor also should be less than this. And then this number, 130 divided by 5 is 26. So we can have 26 multiples of 5. We can have 21 multiples of 6. But there are some numbers in the intersection, okay? In the intersection is, you have to 30 times this, okay? So let's see, 130, 130 divided by 30 is less than 4.3 something, right? So you have 4 multiples of 30, okay? So the answer here is going to be 21 plus 26 minus 4, okay? So that will be, okay, that would be 47 minus 4, 20, 43. Okay. Okay. Yeah, 47 minus 4 is 43. Okay, so this is a direct. You don't need to do subtraction again. Okay. All right, so let's do the next problem. TWA okay, organize a drawing exhibition in the windows. 24 pieces drawing are not by the fifth graders. 22 pieces are not by sixth graders. So this is a okay. I forgot the one sentence here. This kind of school have a first grade all the way to sixth graders. Okay, yeah. There are total 10 pieces of drawing by fifth grade and sixth grade. How many pieces of drawing are not are by other graders? Okay. Yeah, other grade, I mean, six from first grade to fourth grade. Okay. By other students from sixth graders, from first grade to first grade. But so this is a not a trivial problem. Okay, and we assume that this school has a first grade all the way to sixth graders. All right, now how to do this problem? Okay, let me show you the picture. Okay, so we have the picture here. Okay, this is a total number of students. Okay. Okay. All right, we still use the same picture. Okay. 24 pieces are not by fifth graders. So 24 are not by fifth graders. Okay, that means this is the group this is the other grader. Okay, let me see. So this side is actually the fifth graders. This is the sixth graders. Okay, right? If you use this picture. Okay, so 24 pieces of drawing are not by fifth graders. So that means this part is 24. Okay, right? Yeah. And 22 pieces are not by sixth graders. So the other graders plus fifth grade will be 22. There are total 10 pieces of drawing by fifth and sixth graders. These two together is going to be 10. Right? Yeah, 22 means both. Okay, 24, this number also means both. The common area. The other graders means from first grade to the fourth grade. Okay, so how do we do the calculation? I think 24 plus 22. Okay, 24 plus 22. Okay, 24 plus 22. (24 plus 22 is more than the unit of these two, right? Now, if we subtract 10, what do you get? If you subtract 10, This represents the numbers joined by others, double of that. Okay, this is going to be twice times the number of the pieces joined by others. Okay, by students in that's a grade. Okay, so just divide by 2, right? So think about the picture here. Right, 6th grade is 1 piece. Okay, 6th grade. This is 6th grade. Okay, and this is going to be 5th grade. Okay, and in the middle will be the students from 1st grade to the 4th grade. Okay, so what we are given here is this one 24, the other one 22, but that includes includes the same group of students, right? Include this part. Okay, so when add those 24 plus 22, if you not subtract the intersection part, you subtract the drawing by the 6th grade and the 5th grade, then you get the intersection part. Okay, so the answer will be 24 plus 22 minus 10 divided by 2. It's 18. Okay, if you can see the picture like that. Okay, so this is what I'm going to get here, and the same here. Okay, those are the other students. Okay, total is 24. 24 is means for the whole group. Okay, 22. Okay. Yeah, and we don't know how many students in 6th grade, how many pieces joined by 6th grade. We don't know how many pieces joined by the 5th grade, but add them together. Okay, add them together, we know the 10. Okay, total equals 10. Okay, by the 5th grade and 6th graders. Okay. Oh, that's just the name of the school. Okay, sorry for that. Let's do the TWE. Let's say Tom Meadow Elementary School. Right. All right. So now we have another. Well, we probably can finish. We just finished this one. Okay, it's enough. Students from TWE planted some trees. Among the trees, 100 were not planted by the 1st grade. Okay. And 100 trees were not planted by the 2nd graders. There are 32 trees planted by the 1st grade and the 2nd grade. Okay, together, how many trees were planted by other students? Okay. All right, so it's a similar. You draw the picture. Okay, and let's use this different shape. Okay, so 100 trees were not planted by the 1st grade. So that means it's planted by the 2nd grade plus, I also planted by the other students. Okay, so that means maybe 4th grade, 6th grade. So total 110. And the second sentence said that 100 trees were not planted by 2nd grade. So this is planted by the 1st grade student plus student from other grade. Okay, so total is 100. Okay, and this is 1st grade, and together they are planted 32 trees, first grade, second grade. So 110 plus 100 minus the 32. This gives you the numbers of trees planted by other students, but you have to double it, okay? Because there's 2 layers there, overlap here, this part. So you have to divide by 2, that gives the answer, okay? That gives you the answer, okay? So that will be 110 plus 100 minus 32 and divide by 2, so 89 trees. So that is the answer, okay? So the class, the class is over, and